Adi, yes, I'm very puzzled about this phenomenon. About why? Why water and oil have different times to increase their temperature, although both of them are liquid. Okay, did you know about specific heat capacity? Not really. Every metals in the world have a different specific heat capacity. If you want to know about this, let's go to the lab and discover about this. Okay.
Assalamualaikum warahmatullahi wabarakatuh and good morning. My name is Harith Firdaus bin Aswandi and my name is Aiman Zamani bin Zamani. Okay, so today we will construct an experiment to determine the specific heat capacity of different fluid. So, Harith, can you explain the meaning of the specific heat of capacity?
Okay, the specific capacity of a substance is the amount of heat required to increase the temperature by 1 degree Celsius of a mass of 1 kilogram of substance. And in this specific capacity, we use the formula Q equal to mc delta T, which is Q is heat, m is mass of substance, C is the specific capacity, and delta T is change in temperature. And can you explain what experiment we will carry out today?
Okay, so today we will construct an experiment in different type of fluid to determine the specific heat capacity. So we use oil, we use the detergent and water. Alright, so let's reconstruct the experiment.
We weigh the mass of fluid. There are water, oil, and detergent. Okay, we will consider the mass of each fluid, which is 300 grams. First of all, we set up the apparatus, that is thermometer, or supply and retort stand. We wrap the mug with cotton wool that we can assume that no heat loss to the surrounding when heating process. We also fix the power supply. And time is which is 3 minutes OC. We pour the water into the mug. Okay, record the initial temperature, which is 28 degrees Celsius. And we will set the 3 minutes for time taken. We carry on the experiment. So we can see the temperature is rise up. Time is end. Okay, we will measure the final temperature, which is 75 degrees Celsius. Okay, with that we can determine the specific heat capacity by the formula Q equals to mc delta T. The procedure with different fluids, there detergent and oil.
Harith, from this video that I watched, why is the water is moved from depth to the shallow part, but the velocity is smaller? Can you explain me about that?
Yes, Aiman. This is because of refraction of water waves. When water travels from the deep water to shallow water, the water wave is refracted towards normal line. Hence, it can get the smaller wavelength. Hence, it also can get the smaller wave speed. If you want to know more about this phenomenon, we can construct an experiment in the lab.
Okay, so let's go to the lab.
Before that, I think you have to read this.
Alright. Okay, jom.
Hi, okay, let's do the next experiment, which is refraction of wave. Before that, my name is Siti Athirah binti Ismail. My name is Siti Amirah binti Ismail. Okay, it is a phenomenon occurs when waves change direction when traveling from one medium to another medium. In shallow depth, wave speed is lower, wavelength is lower, and frequency is constant. But it's vice versa for high depth, which is wave speed is high, wavelength is high, and frequency is constant. Okay, for this experiment, we use this formula. V equals to F lambda. V is wave speed, F is frequency, and lambda is wavelength. Okay, so let's start.
Okay, so so let me proceed to our experiment. Okay, Harith, can I ask you a question? What is this thing?
This is ripple tank. First of all, we already fill the water into the ripple tank until it reaches 1.3 cm. It's the initial and its original depth for the water. And then we put the perspex block, the different perspex block on 0.5 centimeter.
It is not the different perspex block lah. It is different depth of perspex block.
What? I said we put the different perspex block and it gave a different depth.
Oh, okay, I understand.
The perspex block first is 0.5 and this is 1 cm perspex block. And it will change the depth of the water. Can you explain about this? What's this?
Okay, so this is the vibrator that will make the wave on the surface, at the surface of the water. Okay, so the important thing in this experiment, we must constant hertz that produced by this vibrator. Okay, so first of all, switch on the vibrator, and then in this experiment we constant the hertz into 3.2 hertz. Right, wait.
Until it reached 3.2 hertz of frequency. Okay.
Alright.
Can I help you?
Okay, sure.
Okay.
Alright,
We
so
give the
why
constant.
we low the hertz? Because, Harith, can you explain it?
Because when we lower the frequency, the wavelength become much larger and the period quite longer. So we can mark the between the conservative dark fringe and light fringe easily. And can someone switch off
Alright, so
the light?
so
Yes.
after we switch on the vibrator, so now we can see the wavelength is played on the
White plane.
white plane.
Yeah.
Okay, so now we can see the, what do you call this?
Wavelength.
Wavelength. Right, wavelength. But actually, how we want to measure the wavelength? Can you explain it to me?
Yes, the light source will give the reflection to the white plane.
Oh,
on the wave.
so like that it work lah.
The wave produced by the vibrator. So we look between the conservative white fringe to the another white fringe, and we mark it. And in different depth, we mark it the conservative white fringe, and another depth the conservative white fringe, and then we can mark the wavelength, the length. So for 1.3 cm length depth, it is 8.5, and when the water depth is 0.8, it's 4.5, and when water depth is 0.3, the depth is
It is 4, right?
Yes, it is 4. So this gives us a hypothesis that when the water is depth, the wavelength is higher. So the wave speed is also higher.
So when we can measure the wavelength, so we also can measure the velocity of the wave, right?
Yes.
Using the formula?
Yes, using V equal to F lambda. And
Ah.
it's directly proportional.
Yeah.
And the hypothesis is accepted. Okay, from the first experiment, we used liquid detergent, water, and cooking oil, and we obtained the result that the liquid detergent has the highest specific capacity, following by the water and also the cooking oil. From this experiment, we know that the oil has the lowest specific capacity. Hence, it's required a low amount of heat to increase its temperature quickly.
So for the second experiment that we have done, we can conclude that the water wave that travel from the deep water region to the shallow water region, the velocity becomes slower. So according to the equation V equal to F lambda, we can compute the velocity of water. Alright, so that's all from us. Thank you.